Good evening and welcome back to AP Stats Notes Online. We start Chapter 8 talking about estimating using confidence intervals and estimating. What do we mean by estimating? Well, what we're talking about is not knowing the population parameter. Whatever it is that you want to know on the population, you're not going to know it, short of taking a census. And if we did, then there wouldn't be any reason to sample. There wouldn't be any reason to take samples, and there really wouldn't be any reason for statistics as a whole. So we understand we're not going to know the population parameter. So we're going to try to estimate it. And that is the beginning phases of what we call inference, right? So what is inference? What we mean by inference, we're talking about, and we've used this word a lot, and I know we defined it earlier in the year, but it's easy to lose sight of what inference is. And it's simply drawing conclusions that go beyond the data at hand, right? So we'll take a sample, calculate some statistic, okay, so we're drawing conclusions beyond the data at hand. So we'll take some sample, calculate a statistic, and then try to use that statistic to estimate this parameter, whatever it is, right? So are we going to know for sure what the parameter is? No, not very often are we going to know that for sure. We just have to come up with a way to be somewhat confident that we have a good idea of what the estimate is. So there's two main types of inference. One, estimating we're talking about estimating a parameter now, right? And we do that in the form of a confidence interval. We've discussed that a little bit with our activity about M. And then testing a claim, right? So someone's going to make a claim. 35% of the students did their homework last night here at Franklin Central High School. And to find out if that claim is true or not, then we could perform a significance test. And that's going to be based off of a sample also. And we'll get to that later on, chapters 9 and moving forward. Okay? Don't forget our scope of inference, right? When we are randomly sampling from the population, then we get to generalize our results to that specific population. 35% of the students at Franklin Central did their homework last night. Then I'm going to sample from the students at Franklin Central, so when I make a decision about that claim, it will only be about Franklin Central, not any other population. Right? But if we randomly sample, then we can generalize our results to the population. If we randomly assign to an experiment, then we can establish this idea of cause and effect. So we want to make sure we're keeping a close eye on our scope of inference. Okay? Confidence intervals, and basically what we're talking about with confidence intervals, right? And the first question is, what is a point estimate? A point estimate is a single solitary point value. Think of it as a number line, right? Some number on the number line, and we'd put a point there. And some single solitary number that would be our best estimate at the population parameter, and we'll get that from a statistic, right? And so what is it? It is our best guess at the value of an unknown parameter. Right? And the value that we got from the calculator to try to estimate M, okay? That will be different for different classes just by the nature of sampling variability, right? But that number is going to be our point estimate, okay? And it might be whatever, right? When we calculated an X bar from that population, it might have been 362.4, and that would be your point estimate. If we had nothing else to go on, and we pulled a sample, calculated the mean of that sample, and got 362.4, no matter what it is that we're talking about, and I said, okay, now make a guess what the parameter value was. Well, that would be your best guess, right? You'd have to start there. So our confidence intervals are going to start there. And that's the idea of our point estimate. Okay? Now, the idea of a confidence interval. And I want to cover this up so that we're not writing when we should be listening a little bit, okay? So what is a confidence interval? Well, the definition is it's an interval of plausible values for a parameter, okay? It's an interval of plausible. And we want to make sure that we're using the word plausible and not possible. There's a difference in those two words, and I know you guys love when we split hairs here, but this really isn't, right? Plausible suggests that the set of numbers that we come up with, so off of our point estimate, and we'll get there, let's do that first. So confidence interval, what form is that going to take? We're going to start with our point estimate. So say that 352 or 362.4, whatever we said it was before. And then we're going to add and subtract some margin of error. So, we're not going to hold you to hold your feet to the fire and say, what's the parameter based on one number? We know that there is some sampling variability. And so we're going to use use something called a margin of error to account for that. And we'll talk about that more in just a minute, right? So this will create a set of plausible values. These are numbers that we would not be surprised if the population parameter actually fell in this confidence interval. We don't want to use the word possible because possible suggests, well, what numbers would it be, could the parameter possibly be? Well, it could be any number really is possible. I mean, talking about the likelihood of it being certain numbers, it could be really, really small, but it's still possible. So we want to avoid using the word possible and use the word plausible for our values in our confidence interval. Okay? And that's how we're going to do it. We'll start with some point estimate, and then we're going to add and subtract some margin of error. And you hear margin of error used a lot. Political polls do it a ton, right? Here's in any political race, this candidate has 47% of the vote, plus or minus 3%, or this candidate is polling within the margin of error, which means that from some point estimate, the percentage of the vote that they're getting is that from some point estimate inside whatever margin of error that you decide to set up. Okay. And so next, from a confidence interval, and so the definition here is a set of plausible values, and we'll get to that in just a second. We have to start with some sort of confidence level. How confident do you want to be? How sure do you want to be that your interval contains the parameter, the population parameter? And so the definition of a confidence interval is the expected success rate, right? I want to be 95% confident that my interval is going to capture the parameter. So it's the expected success rate for intervals when we calculate it in the same manner, okay? We want to make sure that we're very careful about that. If I go and take a sample and create some confidence interval from it, and then change up how I'm sampling, then our success rate of that new interval is going to be different. So the expected success rate for intervals calculated in this manner, okay? We would expect 95% of all 95% confidence intervals to capture the parameter we're trying to estimate. Now, that's a lot of 95%, but break this down. We would expect 95% of what we would call 95% confidence intervals to capture the parameter they are trying to estimate. Right? If we're going to be 95% confident that our interval is capturing the parameter, that means that there will be some intervals that don't. 5% of them, as a matter of fact. Okay? So that's what our level tells us. Is if we create our confidence intervals in a similar manner, then if we want our confidence level to be 95%, then we would expect 95% of all of those intervals, and we can create a lot of different intervals, just like we can create a lot of different X bars. We just take a new sample, right? So we would expect 95% of all possible confidence intervals that we can create using the same manner to capture the parameter they're trying to estimate. And I'm sort of hammering that idea home because that's how we're going to interpret confidence level. And we'll get to that in just a few minutes, okay? So this is our confidence interval. We've talked about the point estimate and where that comes from. And then why this margin of error? What is the margin of error? The margin of error is added and subtracted from the point estimate to create a confidence interval with a desired level of confidence, okay? In a 95% confidence interval, the distance between the statistic and the parameter will be less than the margin of error 95% of the time. So based off this same sort of scenario here, if our X bar was 362.4 and our margin of error that we create based on our confidence level was, say, something like 3.5, right? Then what this means is the actual population parameter, the actual mu, right, will fall inside, will fall at a distance less than 3.5 from this 362.4. 95% of the time. Again, it's possible for our parameter to fall outside of our interval. As a matter of fact, 5% of the time, when I create all of the confidence intervals I possibly can, the parameter will fall outside of our interval. So it'll be further than 3.5 away from this point estimate. 95% of the time, it will be inside of this range. Okay, and I use the word range loosely here, not specifically to statistics. Okay. Now, why do we include the margin of error? Because we know that when we take, numerous samples, we're not going to get the same statistic. We're not going to get the same X bar. If I take another sample, I won't get 362.4 necessarily. And why do we know that? Because we know that the numbers will vary from sample to sample. Just regular O sampling variability. And so we want to account for that sampling variability. So the margin of error does that. What the margin of error does not do is account for any bias. Okay, it's the same as before when we talked about in Chapter 7. If something has high bias, how do we fix it? The only way we fix it is to either fix how we collected our data or fix the statistic that we're using to calculate our the formula or the method we're using to calculate our statistic. Larger samples doesn't fix bad wording, badly worded questions, that kind of thing, right? Well, margin of error does not fix badly worded questions. It just helps us account for the fact that we know that from sample to sample our numbers are going to be naturally different, okay? So we're accounting for the sampling variability. Now, interpreting. How do we want to interpret both the confidence interval and the confidence level? Okay, well, I offer up a couple of templates to use again. And we were using templates when we were interpreting probabilities and things like that as well. And so I would highly recommend that you stick to these templates until you get comfortable enough sort of wording things in your own way. You got to be really, really careful when you're wording things in your own way, okay? So again, I don't want you to look at this stuff just yet. So how do you interpret a confidence interval? Okay, here's how we do that. Okay, we are C% confident. And what is that C? That C is your confidence level. Okay, so I'll write that in here. This is your confidence level. And you will choose that right off the bat. Okay? Before you even create your confidence interval, you're going to decide how confident you want to be that your interval is going to capture the population parameter. 95% is a fairly standard confidence level. We can do 90%, we can do 99%, and we'll talk about the advantages and disadvantages of choosing those confidence levels in the future, okay? So we are C% confident that the interval from this to this, and so you know, a couple of different ways you can represent this interval. You can, it'll be what your point estimate is minus, so this guy right here is going to be your point estimate minus your margin of error, obviously, and this guy is going to be your point estimate plus your margin of error, right? Captures the actual value of the population parameter, and so this is all going to be in context. Remember that we always have to add context, and so this is the part where your context comes in. So you can write it as this number to this number. You can write it in set notation, which would look like this, okay, parentheses. So this number to this number, that would be fine too. When we use parentheses and not brackets, some of you are wondering, because those end points, those end numbers are not going to be hard numbers, right? They'll be sort of soft numbers. Though, in other words, statistics is always a gray area. We do parentheses to account for that gray area, all right? Anyway, so point estimate minus margin of error, point estimate plus margin of error, but that's what we're going to do. So, for instance, we're 95% confident that the interval from 10 to 20 captures the actual value of the mean number of homework problems you did last night, okay? Or the mean number of homework problems that Franklin Central students did last night. Whatever the context is, right? But we're talking about how confident we are that the interval itself, and so we need to make sure we give the interval, captures the population parameter. Now, compare and contrast that, or take a look at how differently we start to word things when we interpret the confidence level. So now what we're going to do is this interprets the interval itself. If we want to understand what the confidence level means, that's where this comes in. How do you interpret a confidence level? In other words, what does it mean to be 95% confident? Now, I kind of alluded to this before. Interpreting a confidence level is about the method, not a particular interval. So we'll use this to interpret the interval. We'll use confidence level to talk about the method in which we got our confidence interval, right? And so it'll look something like 95% of all possible samples of the same size from this population will result in an interval that captures the unknown parameter. And we'll do that in context, right? 95% of all possible samples, same size from this population, and this probably needs to be in context also. Same size will need context, depends on what size sample it is, will result in an interval that captures the unknown parameter, right? And the unknown parameter will be in context. So again, it's a template offered up that I think that you should sort of latch onto until you're really, really comfortable with exactly what we want to say to interpret a confidence level. And these two things are saying these two interpretations are saying two different things, right? This one talks about how confident we are in our interval. It talks about the interval. This talks to us about how well or how often our method will come up with an interval that captures the parameter. It's all about the method, okay? So, for example, okay, and we'll take a look at this next example, okay? So, according to Gallup.com, www.gallup.com, on August 13th, 2010, the 95% confidence interval for the true proportion of Americans who approved the job Barack Obama was doing as president was 0.44 plus or minus 0.03. Interpret the confidence interval and the confidence level. Okay? Well, first off, you have to understand that this is your margin of error. This is your point estimate. So to get our interval, we're going to subtract 0.03 from this and then add 0.03 to this. And so your interval becomes 0.41 to 0.47. Okay? Interpret the confidence interval. Okay? Well, to interpret the confidence interval, you would write, we are 95% confident that the interval from 0.41 to 0.47 captures the true proportion, and this is where your context comes in, of Americans who approved of the job Barack Obama was doing as president at the time of the poll. Okay? Yes, it needs to be that specific. There's not a whole lot of play in this. Okay? But that's how you interpret the interval. 95% confident that the interval captures the population parameter. Now, level. Excuse me. How would you interpret level? Okay? And you would do so like this. Now, it's in the method. 95% of all possible samples of the same size, and we can't add in sample size here because we don't know what it is, would result in an interval that would capture the true proportion, and here we go, of Americans who approved of the job Barack Obama was doing as president. There's your context. Okay? We are 95% confident that this interval captures it versus level, which says 95% of the possible samples using the same method will capture the population parameter. Okay? Which, again, level lets you know that 5% of all possible samples will result in an interval that won't capture it. Okay? And so that's how we want to make sure that we're interpreting interval and level. It's really important that we get that down. Points will be lost if you mix and match this stuff up. So on the AP exam and in here, because this is just proper, again, understanding what each thing is telling you is just proper statistics. Now, this interpretation you will always need to do when you construct a confidence interval, okay, automatically. You will automatically interpret the confidence interval, okay, all the time. If you're asked, even if it doesn't ask, you need to interpret the interval. That'll be part of our 4-step process, and we'll talk about that a little bit later as far as our state plan do conclude goes. This you only do when asked, okay? There's no reason to do both, okay? Some questions will ask you to interpret the confidence level. Some questions won't. Some problems won't. Okay? So you're going to interpret the interval every time you construct it. You're only going to interpret confidence level when you're specifically asked for it. All right? I think that's enough for now. So we'll stop here, pick up homework, which is going to be in the text that I sent out in the next class period. Okay? See you guys then.